Well, that looks pretty good to me. Inside and outside running about the same. Just using my surface gauge with my little pointer, and I just eyeball this ring that's set up on this faceplate in my Clausing lathe. Alright, today we're starting a housing adapter. I'm just gonna kind of like give you an idea. Alright, so it's a flat ring and it has a little shoulder out here. So it's basically taking up 2 bolt diameters for a transmission to bolt up to the back of an engine, or an engine to a gear, or whatever. The specifics aren't exactly, it doesn't matter. I got the drawing of the part. I had my supplier go ahead and plasma cut, or they might have even underwater flame cut this. They really do a nice job. And then I just hit it with my sander just to make sure there's no draw, so we can hold this right to the faceplate. And I haven't had the faceplate in the lathe in a long time, so it's kind of fun to set something up like this. All right, now that we're running true, I can put this out of the way here. This side here is basically going to be the complete flat side. So we're going to bore it to dimension. We're going to face out till we get to, or just before we get to our clamps. And then we're going to trade off, and we're going to move our clamps on the inside, and then we're going to finish the face and turn the outside. And we're just going to bring that outside diameter and the inside diameter as close to the faceplate as we can. And you know, you say, oh, I hope I don't hit the faceplate or whatever. But you know what? If you're turning this round and you happen to touch your faceplate, you kind of put another ring on your faceplate. And having rings like the rings on a 4-jaw help you dial the next thing in. Food for thought. And not. I actually use these 4 squares right here to kind of eyeball it. And I use a 3/8, and I use a stud that bottom goes through the T-nut, so you can jam it. And then I like to just adjust it up and down until I get the visual, and then I kind of side to side, and then I clamp it, and then I can put the surface gauge up, and then I can tap it with my lead mallet, and that's kind of how I put it together. All right, let's put it in gear and get some motion going on here. I'm going to reach out with my boring bar with an insert on it, and I'm going to use that to cut, because it gives me that C&MP tool bit with an extension out from this, so I'm not overhanging my bed as much. Okay, I just spent about 5 minutes trying to get you in the best position that you can possibly be in to see this cut in the face on the inside and everything. I tried to get you're on the back side, of course. This bit angles down a little bit this way here, but this is the tip right here, so you can barely see that point right there. All right, first I want to go ahead and I'm going to bring this in, and I'm going to go ahead and touch my plate there, and I'm going to set a 0 there. You either get the 0 or you get the noise. One or the other will let you know that you're at that 0 point there. Whichever one comes first. All right, let's put this back in gear. I think I'm going to try it at that service feet per minute right now. It's not bad. It's pulling it off silver, And then it's turning gold right about there, and then purple out about where my pin is. I'm going to have to get out my large inside micrometer set, which is going to be pretty neat to use as well. They sit in the cupboard a lot of the time. Says we got another 100. It looks like another 100 in there, right? Another 50. Another 10. It says I got 5, but I think that's, we're going to reset the 0 right there. Okay. We better take a measurement just up. Let's just say I have experience in thinking that you got a mile to go and you don't really have a mile to go. All right, so let's check that diameter. Okay, 14 inches, 90 thousandths. $14,201, almost maybe 3/4 of a tenth, 3/10, 7/10, I should say, over. This is a nice finish minus my back cut when I pull back, so I think I'm going to dial in. We need to go to 250, so I'm going to take it right to 25 per side here on the dial. And we're going to go in. When we get to the bottom, then we're going to come out away from it, and then that inside bore should be done. $50 thousandths, 40, 30, 20, 15, 10, 5, bumping it in by hand, 2, 1, okay, 0. pretty darn good. 14 inches, 2, 50, and 9/10. It was a fractional dimension, but sometimes even when it's a fractional dimensions, it's kind of fun to see if you can hit your mark, especially on something that's oddball like this. And it's not a bad finish for a A60 steel ring. All right, now we're going to go ahead and we're going to come out and we're going to skim. We're going to check our swing first on each one of these and kind of set a 0 on my dial here. So we adjusted each clamp one at a time, so we didn't change any position of the ring. We're still running concentric on that inside. That's the whole thing, is we never let the ring slide on the faceplate. All right, so we change one clamp at a time or just one clamp at a time. It looks close, but I'm giving it 100 thousandths at least clearance in there right now. Okay, let's see what that looks like in there. All right, I'm going to come in and touch just to make a visual line, and then I'm going to set 0 on the dial. Okay. Now we're just going to touch off here. We're just going to take bare minimum to clean it. There's 10 thousandths right there. Okay, we got to change our feed direction. Otherwise it's not going to come out. Okay. Okay, I'm going to speed up the speed now, or the feed. As long as she's solid to the faceplate, you don't get a singing like you would if you were forged on a big ring. You would get a lot of singing in your ring. You got to wake up from your daydream. Because when this is running, you don't really see those clamps. So you got to pay attention. We're a 1/4 inch or so away from our destination. And then we can stop it, and we'll move our clamps to the inside, and then we'll be able to move out to the outside and finish the diameter and the rest of the face. We got another 110 thousandths to go here. $50, $30, $15, $5. We're there. From your angle, it actually looks a little bit more, but it's really, It's really only that's 100 thousandths. That's about 150 on that one. 150 on that one. About 120. So we did have one that was wrote. That was the closest one. Okay. Little chamfer on the tool right here. Make sure our clamp's all clear. I hate to hit one of those now. Okay, it's not sharp anymore. Sometimes I forget I zoomed you in and you're not seeing the wide span that I'm seeing here, okay? But basically I just turned this around, slid my bar out, put it in the other way so that I could hold it so that this surface right here is basically breaking that. Put a chamfer on it, just to break it, not any certain degree at all, just eyeball. All right, now we're ready to change our clamps around. All right, I picked up some of the chips here and kind of cleaned up a little bit and changed days. This is the following day now. But you don't know that when you're watching a video. You don't know how many days something takes or whatever, or I might stop on this project and go do something else somewhere else and whatever. All right, so we're going to take and we're going to move two of these at a time. I'm going to move this one and that one. Now our ring, 16 and 1/8 is our face out here to the shoulder, where we'll be cutting back a shoulder on the other side there. But this face right here, all we need to do is continue off on this face right here. So the next time we grab on the inside, when we flip this ring over, we're going to be paying attention to how much meat we have to grab a hold of on here. All right, so we'll probably do the same thing on the other side. It'll be clamp on the outside, then move to the inside, because our finishing machining will be on the outside, cutting the shoulder in on the outside, because there's an 1/8 inch thick lip that sticks out a good portion of this. That's going to be adequate right there. When I change the clamps, I kind of I'll put them in the same exact position as I did that side there. I think it just kind of helps hold the balance in. Not that it's going to be that far off for how big this plate is compared to the few accessories we got here. Okay, we're happy there. We're going to go ahead and give it a spin here. Okay, there's two ways to. One is an eyeball, just to eyeball the center register. It appears to the naked eye to be running true. Once we create a cut on the outside, we'll be able to take calipers and we'll check the thickness or the width of the ring. And that will tell you if we're turning concentric to the inside. All right, so if you come up with similar measurements all the way around, you're going to be nice and true. All right, now I want to go ahead and I want to carry this face off of here, and I want to match that height right there. So I'm going to go ahead and take my Sharp'em, and we're going to go ahead and just put a line around here. next to where we're going to be touching off. It should be all simultaneously. It shouldn't be skipping. If it was skipping on this color, then that means that somehow the thing lifted or is warping. But there we go. All right, now we can touch off of here and take a skim cut, and we can come in and we can just barely remove that color and continue that cut off the part. Okay, we're running it backwards here. And we're gonna come in. We got our bit upside down. We got a pretty good angle there. I'm a little fast. Hello, Keith. Okay, I slowed it down a little bit. I took care of my phone call at the same time. Okay. I forget if we took 5. All right, we're gonna set here. We're gonna just go one at a time here. It's 3/1000ths. 4/1000ths. 5/1000ths. 6. 7. There's 8. Maybe it was 10 that we took. There's 9. Okay, I'm just rubbing that off of there. Okay, I'll engage it. And we're feeding out. That was 9/1000 from that surface there, so I thought it was pretty close. We're lightly, barely skipping. We're getting a little flash right in that area right there, so I'm happy. We're going to be close enough to that surface. I'll be happy with that. We already came in and touched the faceplate like we did on the inside, and I'm just going to come in and touch the outside now. Okay, we're going to turn the outside to where it comes down to 17 inches and 3/4, 17 and 3/4 inches. Another 30. $10. Okay, I'm gonna call that. That's 2,000 shy. And I'm just gonna roll this over real quick just to. Okay. Here again, we came in and almost right to it, but we didn't touch it. So, no ring today. Okay, we're just scaling this diameter here, and we want 17 and 3/4, and looks like we might be 10 over. Another 20, 10, we're right there. I'm gonna back out, I'm gonna come out, okay. All right, let's see what we got here. That looks right on the money. If anything, it might be just a couple thousandths. No, I think it's pretty close, right on the money. 17 and 3/4. I went to the cupboard. I don't know if this is wide enough for us to run our pie tape, but this is my measuring tool for anything over um, 12 inches. I have micrometers all the way up to 12. I might have one that's a little bit over 12, but pie tapes are pretty cool. Okay, I'm gonna have to hold this and just take a picture because I can't see. Let that hang on around there. Otherwise, there we go. Of course, I don't have anything ready. All right, I'll tell you what. Let's see. There, I got it in video mode there. At least you can see. There's the 3/4 mark right there. Pretty close. I'm going in next week for an eye exam because my glasses aren't or don't seem like they're working as well as they used to. Once a year I used to get eye exam, and then I get new lenses because I use them. I get 2 pairs, titanium frames, and this is what I use for safety glasses as well. All right, we're gonna chamfer that, and then I'm gonna show you how I'm gonna turn this ring around and get it pretty darn close in place right away, quickly. Before we break this loose, we want to locate this ring to the faceplate. So we're going to take 2 of our small 1/2-inch toe clamps, and because they're bevel on this side here, we're going to put them on upside down in relationship. Instead of flat down on the face, we're going to turn them over so that this doesn't go right into sharp into the corner. So then we can use that face right there to be an outside surface for support. Now, we can grab that square and that square pretty easy. We can grab that square, and then that way we can work these 2 slots here, the first on it. So let's go ahead. We're gonna put one in here, and I think we can just do it with the 1/2-inch nut there, and then on the back I can just put another 1/2-inch nut here. Put that flat as possible. I'm just gonna tighten that down right there. All right, we're gonna put this one here. As long as we have a little span between them, it should rock and locate that right in that same spot there. Close enough. We're gonna be tapping it and dialing it anyhow, but this lets us pull it off, really not sweat it, and put it back on and have it, well, I don't know. You want to guess what we can get it within? We'll just shoot for getting it right back in 0. All right, that's as close. I really can't feel if there's anything there. I could take a feeler gauge, put it in there. All right, now we'll go ahead and we'll pull off our clamps. Now we're going to pull them all the way out to the outside here, because we're going to take a skim on the inside on out for the full face that we're going to be exposing on the other side, and then the other outside is going to get cut with the shoulder. So we'll set up, we'll reverse them after we do that. So I'm just going to go ahead and leave them all the way out because we want to make sure the face is clean and clear. We're going to leave that one for last. Okay. We'll set that down here for right now. Okay, make sure that face is nice and clear. All right, now we're going to put this back in. We can just pull this stud up to the top here because we're going to put it right on the out. Yeah, we're going to put it on the outside. We want to turn the inside first. That's what I said the first time. That indicator is really not sitting in there exactly in line or whatever, but I'm just giving you an example of relocating your part in there pretty close so that you can tap it into place. Now we're going to go ahead and we're going to get in another indicator, probably a little test indicator. Okay, I'm going to call that true enough right there. I'm 4 within 0.02. Touching. We set 0 there on our dial. Okay, come back out, come back into the 0 we had. All right, now we can do that direction we were going now. All right, we're going to take our face cut across here and then take a thickness measurement. Finished the first, or the first pass. It's the only pass we made, but it's the first one. And I'm just gonna measure from here to here with my depth mic. I'm just gonna put it out here close. We got 1/8 and 15/32 is our combination of thicknesses that make up the total thickness. So that would be like 19/32, something like that. Which should be like 593 or something. We got like 604. Yeah. 604. So we could actually take 10 thousandths off of there and will be the right thickness. I want it to be the exact thickness because this ring is putting a drive to a driven, and sometimes you need to have exactly the right thickness in there because there's engagements of shafts, clutches, and all kinds of other things as well. We're probably fine, but let's make it right to the drawing. I got the extra width on the material. And also, let's just double check and make sure our face is, this diameter was supposed to be 16 1/8, and we actually got 16 3/4 there. So we'll do this once more, and that's a done deal, and a chamfer, and then we'll move the clamps to the inside. Okay, the chamfer. Okay, we touched the back wall. We came out our 1/8 of an inch plus another 25. So we're going to leave 25 thousandths while we make all these plunge cuts until we come down to the diameter that that minor diameter is going to be. Okay, just before this cut here, we were about 60 thousandths from our finish. I took 25 aside here, so it's going to bring us in and pretty close. And then we're going to come and we're just going to bring that to finish size, and then we're going to face that off till we get 1/8 thickness on that back flange there, and then chamfer it, and this ring is done. Okay, this is supposed to be 16 1/8 of an inch, and I'm looking at 16 1/8 of an inch right there. If so, then the difference between 14 1/4 and 16 1/8 would come up to like 1 7/8. Double or half of that would be 9375. I got 933, 933, 934. We're going to call that the diameter. So what we got left now is this thickness right here. Let's see, we can probably get in over here. I get like 172. Remember I said I gave it about 50 thousandths, I think? All right. No, I said 25, but that's not been faced, that's just been plunged, so it does have some high spots because the clearance on the front of the bit. I think we got to change our feed here. That'll be bringing it out. We got to increase our feed. Yeah. Okay. Okay, so I'm just coming into the nitty-gritty right now, cleaning out that corner. All right. That looks good. All right, we're gonna check our thickness here. .128 to 129, I'm reading around this thickness right here between the slots. We're looking good. All right, guys. I hope you enjoyed a little demonstration on how I use face plates and maybe a couple tips along the way, hopefully. Anyhow, just wanted to share this part of the project, and until next time, get her done.